Hi there. So for this problem, we need to determine how large the mass of the bus A have to be and to prevent any motion from occurring. So we assume first that the static coefficient is zero point 0.3 and we know the value of the mass mb, which is attached through string with the mass ma. So the first thing that we need to do in this kind of problems is to draw all the forces acting on each of these bodies. So for the mass for the block A, we have the following. We have the normal force and the weight. This just acting on the y component, and in the x component we have a tension to the right that we call T, and a friction force that is always in a position of motion and that we call Fr. For the mass B, we only have forces acting on the y component, and those are the tension and the weight. The tension is the same. We're going to call the first one weight A and here weight B. The tension is the same because they are connected through the same string. So for the now applying Newton's second law, for the first one we obtain that the forces in the y component are the normal force minus the weight, and this is equal to 0 because the block is not moving in the y component. Now, the x component of the forces are the tension, positive, because we set it to go to the right, and minus the force of friction, which opposes the motion. So in this case, it's equal to 0 because we want to prevent the motion. We want the mass of the blockade to prevent the motion. So we set this equal to 0. For the mass B, we have the following. We only have forces in the y component, so they are the tension minus the weight of the block B, and this is also equal to 0 because if the mass A is not moving, then the string is not moving, and the string is the one connecting with the block B. So if A is not moving, then B is not moving, and neither. Now, what we are gonna to know, first we need to remember that the friction force should be when we are talking when we are talking about an static condition, this should be less or equal to the coefficient of static friction times the normal force. So having this in mind, we just need to obtain from all of this. We are gonna go this 1, 2, and 3. So from one, we obtain that the normal force is equal to the weight of block A, and we know that the weight of block A is just its mass, which is mass ma times the acceleration due to gravity. Now, from equation 2, we obtain that the tension, the friction force, is equal to the tension. And from the last equation, third equation, we know that the tension is also equal to the weight of the mass B, which is equal to the mass of B times the acceleration due to gravity. So what we can use in here is simply substitute the value for the normal force in the force of friction, and then equal this to the weight of the block B, which is also the same to the tension. So that's what we're gonna do. We want the minimum mass of the block A such that the system is not moving. So we have that maximum when this is equal, to the coefficient of static friction times the normal force. We know from one that the normal force is equal to the mass of A times G. And we know that the friction force is also equal to the tension, but we know that the tension is also equal to the weight of the block B. So we have this, we can eliminate this too, and we just simply solve for MA, which is the one that we want in this case. So MA is just simply MP over the coefficient of static force, of static friction. So the mass of the block MP is given of 2 kilograms. So we have 2 kilograms and the coefficient of static friction, which is 0.3. So putting this into the calculator, we obtain a value of 6.67 kilograms. So this is the mass, the minimum mass that the block A can have so that the system is not moving with that given value of the coefficient of static force. So that's it for this problem.